Hi, everybody, and thank you for joining me today. Today, I want to spend some time talking about modern architectures and observability and some gaps that the current three pillars of observability don't really capture or reflect. It's no secret today that companies are adopting new technologies to achieve their business purposes at rapid rates. Research shows us that customer experience is king, and as companies move through their digital transformation, the goal is to move faster and ensure that they are delivering the best possible customer experience. The ability to move faster and scale on demand is crucial for the success of companies in the new digital age. Distributed systems built on microservices and serverless technologies enable companies to move faster and ensure that they are meeting their customer experience goals. However, as we continue to shift into these new modern application architectures, we are entering into new landscapes that have increased complexity. And while problems with legacy architectures may have been well understood, we're moving into a world where problems is not as well understood. These powerful technologies are enabling us to deliver software at the speed and the scale that we need. However, there comes a cost with increased complexity and a shortage of well-established tools. And the evolution of these modern architectures to support these next generation cloud native applications has led to a lot of paradigm shifts in how the dev, ops, and security teams can work together and need to work together. Today's rapid CI/CD models are presenting us with a lot of competitive advantages. Companies are able to obtain a much faster release cycle. This is enabling them to get code into customer hands much faster. And quality of service measures are being built into the development process to ensure that applications are performing in the manner that is needed to achieve the right customer experience. Developers have more ownership and also more responsibility, and that is actually improving the overall delivery process. However, as a result of these advantages, a deeper understanding and engagement in user workflows is happening as well. So these advantages that we're seeing in the CI/CD process that are enabling us to accomplish a lot of great things, they're also creating challenges within security. Systems are becoming more and more distributed, and well, with multiple moving parts that are working together. And this leads to more perimeters that need to be protected, spanning many different areas. Microservices and containers powering these distributed systems results in many big chains of inter and cross communication. And the tool fragmentation continues to grow. This is leading to gaps in holistic views across these different complex architectures. And all of this is driving the need for new DevSecOps workflows. Security is being built into the DevOps models that have really come out of these new architectures together. And dev cooperation is really required to fully understand and secure the application. And this is requiring the logic of the application to be well understood by multiple parties. And it is also requiring the cooperation of the ops team to ensure that the environment dynamics are also captured and accounted for. And everyone needs to be on the same page in terms of this knowledge that is spanning multiple teams to ensure that security is accounted for and who is responsible for which aspect. And this also drives the need for common monitoring and analytics tools that can solve a wide array of use cases for the demands of these new DevSecOps workflows. As these modern architectures are driving modern processes to evolve, we must also ensure that our visibility into these problems and attacks that we continue to see expands and grows with it. It is critical to ensure that you have the right observability in place to fully monitor the health of your applications. Many of you are probably familiar with the three pillars of observability, and to some, observability quite simply means logs, metrics, and traces. Metrics are numeric representations of data that are measured across time. And metrics provide you a really good indicator into what is happening inside of your systems. Logs are immutable records of distinct actions that have taken place in the system across time. Logs help you understand why your system is behaving the way they is. They complement metrics by bringing context in the behavior that your metrics might be showing you. And traces is our third pillar, and traces represent really the end-to-end request flow for a distributed system. Traces help you understand how the system is behaving at a transaction level, giving you the ability to see at each request exactly what kind of calls are being made, and what is happening across that system. Now, at the center of the three pillars is really your application. After all, your application is what you are trying to observe, to ensure if it is healthy, to ensure that it's operating the way you expect. Your applications emit logs, metrics, and traces, and they help you observe how it's behaving in its health. Now, an analogy that a colleague of mine uses to explain how these things fit together that I think is great is the analogy of a hospital visit. Imagine that a patient is admitted to the ER. The hospital runs various tests to determine the vitals of the patient, things like heart rate and blood pressure, for example. These are metrics that give us clues into what might be going on with that patient, much like CPU or memory of a node can tell you what is happening on that specific node. Now, the doctors then learn that the patient was hit by a car from the EMTs that delivered the patient to them. This helps the doctors understand why the vitals are the way they are, much like logs can help you understand why a system is behaving the way that it is. And of course, there's the story of how the patient was hit by the car. Perhaps the patient was on the way home from work and was hit while crossing the street by a driver who ran a red light. This story brings full context to the situation and the ultimate actions that landed the patient in the hospital. And this is very similar to how traces can tell us a story of what is happening in a distributed system at the transaction level. Now, as I mentioned earlier, when people think about observability, often these three pillars are what come to mind. But does this really define observability? If I have these elements in my application, do I truly have an observable system? I recently read a book by Cindy Sridharan called Distributed Systems Observability. It was a great read, and she had a definition of observability that really resonated with me personally. You see, some people get stuck on this idea that if they have an application that is emitting logs and metrics and traces, then they must be practicing observability, and therefore their system must be observable. But the truth is, an observable system means much more than that. It's not just about logs, metrics, and traces. Logs, metrics, and traces are simply tools that can help you understand how a system is behaving when they're implemented properly. Having an observable system means that the system was built with some key principles in mind. Everything that can go wrong will go wrong, and no complex distributed system is ever 100% healthy. It is simply built to withstand those kinds of failures and handle those failures gracefully, with indicators to explain its health. Distributed systems are widely unpredictable due to the complex web that it consists of. Multiple services talking to multiple services in this complex web of intercommunication. It is impossible to predict all the complex permutations that various states that system may end up with. And so it's important that we understand that, and we understand we have the right observability to at least know what's happening in the system when we enter these complex states. Now, embrace the fact that everything can fail at every phase of the software delivery lifecycle. Ensure that you plan for it and implement the right set of logs, metrics, and tracing that can help you understand the state of the system at any time and as fast as possible. Embracing these principles across your software delivery process, all the way from design to development to delivery to deployment and operation, is going to help you create a system that is observable. But we still have a missing crucial element in observability and the three pillars. What about security? As we talked about earlier, DevSecOps means that security is embraced in every step of the DevOps lifecycle. And while we have done a decent job of breaking down the wall of confusion that separated the dev and ops team, we still have walls up around the security team. To truly practice DevSecOps, we need to factor security in throughout the entire lifecycle of the application, including its observability. After all, if we want an observable system, we need to be able to truly observe every aspect of it, not just the performance and health of it, but also the entire operational lifecycle of it and the security elements of that. You see, security is too often treated like an afterthought. And it's really time to make security a first-class citizen across this application lifecycle. You need to take a holistic view of security, and you need to make it part of your DNA. You need to ensure that you're building code analysis into your continuous deployment chain to ensure that you're analyzing code for any security risks and automating that as a part of your continuous delivery pipelines. Implement the right access control models to empower teams to recommend change and also implement those changes. It's also crucial to enforce operational and security hygiene and processes through things like compliance monitoring. You need to be able to detect, investigate, and remediate threats across these distributed services. And you need to implement continuous vulnerability scanning and remediation to ensure that you are being completely aware of the vulnerabilities that your system may be facing. And it's also important to empower your developers with various security knowledge. The more that they know, the more that they can help on their own and they can also plan for through their day-to-day jobs. Now, we talked a little bit about the 3 pillars, and we've identified that security is a crucial element to have observability. And I think it's time that we introduce this new pillar of security to our 3-pillar models. Embedding that security DNA model into the current 3 pillars is a must to ensure that you have a completely observable system. Observability is not just linked to or limited by systems that emit logs and metrics and traces. There's a whole set of principles that help you define if you've made an observable system and help you diagnose the health of the system. But a healthy system truly means a secure system as well. The security of applications is crucial to your ability to operate those apps and deliver the customer experience that is needed in this day and age of modern applications. It's time to shift our thinking, and to ensure that this is successful, we need to ensure that security is a crucial piece of observability. Now, security indicators, they're not limited to just a particular element of the 3 pillars. In fact, security events and the data needed to properly investigate a security threat really come from all the existing 3 pillars. Metrics, logs, and traces are all types of data that can be used to also diagnose security threats, in addition to being able to observe and monitor and troubleshoot an application. Let's take a look at some security indicators that make sense within these new pillars and some specific examples. First of all, some common use cases for securities. And many of these will resonate with Kubernetes, but they're also going to resonate with any application today. The ability to identify and prioritize and resolve vulnerabilities across all environments. That includes your underlying infrastructure, the hosts, any artifacts that you might be using, or container images or container registries. Identifying runtime threats in your Kubernetes environment is also a crucial use case. And of course, the ability to correlate across different data sources to determine the origin of the threat and vulnerability, but also how deep that attack got. And of course, you want to be able to aggregate compliance record keeping across multiple Kubernetes clusters and cloud environments. After all, you're likely running a hybrid infrastructure where maybe you have multiple clusters spanned across hybrid, on-prem. You also probably have some legacy systems in their place. You want to be able to aggregate consistent compliance requests across all of these elements. If we take a look at some examples of security events that are pretty common, for example, vulnerabilities. Whether an image contains some kind of vulnerable jar file or some other vulnerable package or software, or whether the underlying operating system packages built into that image or on that host even are vulnerable. Also looking at runtime processes for applications or processes that were launched but maybe not used in the different runtime models. And when it comes to security metrics, it's also important to look at various compliance violations. Let's take a look at some examples of those. For example, for our containers, the ability to detect when containers are running as root is important to be able to measure compliance. Also, detecting if there are proper limit and request settings on things like memory and CPU. This ensures that our container cannot take over and infect the whole system or cause a downstream cascading effect. When it comes to hosts, being able to ensure that SSH root logins are enabled, but also that login and logout events are not collected. We want to be able to capture these kinds of things as they're critical to being able to detect potential compliance violations. When it comes to our container images, detecting if private keys are stored in an image, or if an image was created with a root user. These can also ensure that we are running secure images as well. And of course, there's also various file activity, such as looking for suspicious file written events to /var. So these are just some examples of the possible compliance violations that might be encompassed in that security model as well. Now, I'd like to take a look at what I think to be a real working example that I think embodies this new model of the 4 pillars of observability. I think Kubernetes is an excellent example of a platform that embodies the importance of having visibility into all 4 of these pillars to truly define that we have an observable system. There are many different streams of data within every Kubernetes cluster. And in order to observe Kubernetes, you must capture and you must have visibility into these various streams of data. For example, logs and events come not only from your applications, but also from the Kubernetes control plane. And these streams can provide valuable insights into why Kubernetes or your application are behaving the way that they are. FluentD and FluentBit are powerful data aggregators that can not only capture logs and events from your Kubernetes cluster, but can also deliver them to a variety of logging backends where you can observe and do further analysis beyond simple tailing of that log file. FluentD and FluentBit, like Kubernetes, are core projects in the Cloud Native Computing Foundation, as well as the fact that they are built for cloud native applications and architectures like Kubernetes. Now, like logs, metrics are also key to Kubernetes, and they're a core element that Kubernetes exposes. And metrics not only come from your applications, but can also come from the components of Kubernetes itself. Metrics give you clues into what is happening across the board. Now, Prometheus is the de facto standard when it comes to Kubernetes monitoring. It was designed with highly distributed and ephemeral environments in mind. And like FluentD and FluentBit, it is also core to the Cloud Native Computing Foundation stack, and the second project contributed by the Cloud Native Computing Foundation. And while Prometheus can be used to store metrics, it can also deliver that data to a variety of different backends. And this is achieved via the capabilities of the remote storage and remote write capabilities. And this is very powerful when you want to have much more long-term storage on your metrics data for more long-term trending and being able to map those metrics back to KPIs that are important for your business. And of course, there are many security-related elements within every Kubernetes cluster. And there are many commercial and open source solutions that are built to help you secure your Kubernetes clusters. These solutions are all integrated with key components that make securing Kubernetes unique. Many of these solutions offer their own security backend to house and analyze this data, but they also integrate with a variety of other security backends as well. And of course, it's also worth mentioning the importance of metadata. You see, Kubernetes and modern applications like Kubernetes, they're built with rich metadata. Things like the nodes, the pods, the pod labels, the containers. These are important bits of information that are crucial to understanding that Kubernetes system and the applications that are running inside of that. Ensuring that metadata is captured across all of these streams of data, from logs to metrics to events to security-related data, it's really important to ensure you capture this, as the metadata acts like a glue. If you know all this information, you now know a lot about how these bits and pieces fit together. The ability to go from a security event to a metric or to a log or to an event or in any order can be made possible by ensuring you have consistent metadata during your collection process and your data aggregation. So as you can see here, Kubernetes is a great model of why 4 pillars are needed to ensure that your Kubernetes cluster and everything inside of it is not only observable, but also healthy and behaving the way that you expect. You need to have visibility into all of these elements today in order to be able to effectively observe Kubernetes and your applications running inside. Now, however, one challenge here is that many of these solutions are fragmented. You see here in this example, we have a logging backend, a metrics backend, and a security backend. And this can create a lot of headache and context switching and the ability to have to learn multiple tools. And even though you may have the metadata, it could be difficult to do this kind of cross-signal correlation and trace across these different streams because you have different tools. You have different tools that may or may not work together. In order to have true observability of a system, you need to have a platform that is built with DevSecOps and the 4 pillars of observability in mind. Being able to correlate across all of these different signals is crucial to your ability to quickly identify and resolve issues and threats that may arise in your application. It isn't just about logs or metrics or security or events. It's about these things holistically. And it's about the relationship of these signals, how they work together, and what they can do to give you a comprehensive picture of what is happening in your system. As our architectures continue to evolve to more and more distributed systems becoming more complex, and our processes and workflows converge onto DevSecOps, and the lines get a little bit more blurred between developers and security and operations, so too must our definitions of observability and our tooling to support this new era of modern cloud-native applications. Thank you for joining me today, and thanks to our event organizers for having me. If you take one piece of information from today's presentation, I hope it is that security needs to be baked into every element of our day-to-day when it comes to the full life cycle of software development. The three pillars have served us well, and as we continue to move forward in this new era and new modern architectures and new modern applications, we need to look at that as well, and we need to make sure that it embodies everything that we are trying to achieve through software delivery. Security is too often treated as an afterthought and too often left behind. There are, in fact, 4 pillars of observability that we should always have in mind when it comes to our workflows and our processes, and they should be built into every aspect of our software delivery life cycles. And in order to have true observability, you need a platform that embodies these 4 pillars and a platform that is built for these new DevSecOps workflows. Thanks very much.